So my name is Jorge Ramos, and thank you for the introduction, Stephen. So before I dive deeper into my research, I'd like to give a brief introduction on the origin of this project. So why? I've been studying music for the past 20 years, but only after going through an extensive classical musical training was I introduced to electronics. As I delved deeper into this new world of sounds, I began to notice that my own perception of writing to acoustic instruments was shifting. Slowly, I found myself trying to shape the instrumental sound the same way as in electronics, especially while working with synthesizers. So in reality, through this practice, I was progressively learning how to listen to sound, and more importantly, how to, as a composer, shape the sound itself. Nevertheless, this was only the starting point. Also, I began to redefine my previous and very classical idea of an instrument's nature, whether it is natural to consider its physiology and geometry or its timbre and sonic properties. As an interesting example, here is how Sakamoto rethinks the nature of the piano sound.
産業革命が起こって初めてこういう楽器が作れるようになったんですね。で何枚もこれ木の板が6枚ぐらいかな重なってるのを強い力でこういう形に半年ぐらいなどかけてね型にはめるわけなんですね。あるいはこの弦もこのストリングスも全部合わせると何トンという力が加わってるらしいんですね。でもともと自然にある物質をこう人間の工業力とか、文明の力で自然を鋳型にはめる。で音も情緒が狂ってくるんで、もう人間は狂うって言いますけども、全然狂ってるんじゃなくて自然のこの物質たちは元の状態に戻ろうと必死になってもがいてるわけですよね。
So, as you might know, Sakamoto also works extensively with the electronic synthesizers, especially in film music. So afterwards, I spent several years practicing how I could achieve the best of both worlds, and consequently to blur the line between the acoustic and the electronic sonic realm. So can I pass? Followed by my master's degree in electronics, where I began to technically address these questions through my creative practice and to challenge the traditional definition of orchestration. With that said, my current doctoral research poses the following questions. In what ways can technology and electronics influence the timbral result of contemporary orchestration practice? Additionally, throughout this discussion, some other subsidiary questions will arise and be addressed by this research. How can electronic sounds and DSP techniques influence orchestration practice? In what ways can techniques of electronic music composition inform timbral blend? How might a composer explore site-specific sound spatialization through the act of orchestration? In what ways does computer-aided orchestration impact on compositional processes and results? And finally, what notational issues and solutions arise from the above techniques? So, by drawing upon electronic music composition techniques and timbral shaping tools, this project challenged the boundary of orchestration and explores processes that inform orchestration decisions. I will be using new approaches to timbral blend, spatialization, and acoustics, real-time orchestration, computer-assisted orchestration, and extending the timbral palette by rethinking the ideals of spectral composition. Through the resulting portfolio, this project aims to create new sound worlds and audience experiences, while situating my distinctive approach in relation to other existing practices. Oops, this gone wrong. Okay. Also, a supporting commentary will illuminate the deep pre-compositional research that informs my orchestration practice by identifying the techniques and evaluating their application. To explore such concept, it is vital to conduct a practice-led autoethnographic research. This allows for full creative exploration and application of site-specific tools. Sorry, I can't see my notes. Okay, I can drag these down. Too many controls on one screen. Okay. So, sorry, the slide before. By acknowledging the influence of electronics on my orchestration approach, I hope to uncover new findings in this area by combining electronic and non-electronic systems into what I consider to be my orchestration discourse. For the purpose of this presentation, I will be focusing on the premiered work so far, here marked with an asterisk. Moving Sources was the pioneering work of this doctoral research. The initial purpose of this composition was to pave the way for the development of a future larger scale work, point of departure for symphony orchestra. It is therefore a study that facilitated experimentation with and evaluation of computer-assisted processes. The compositional process borrowed from traditional spectral procedures, hence the use of spectral analysis as established by the spectral composers. To do so, I first conducted a spectral analysis of the given audio sample with SPEAR. This allowed me to select and extract only the strongest harmonic partials. Before I proceed, let's hear the original sample. So after reducing its spectral content to only the strongest partials, I was then able to resynthesize the resulting spectrum back into an audible format. So in the end, this process made it possible to extract some useful pitch material to be the basis of this composition. So moving on. As the composition material, my orchestration approach was also derived from the idea of wind chimes. However, in this case, I was intuitively translating the concept of wind chimes as a physical instrument and its sonic properties into the instrumental domain, the classical orchestra. I then processed these musical ideas through electronically informed orchestration processes, such as the following extract. This example shows the simultaneous use of a slowly decaying delay coupled with a progressive filter sweep from the highest to the lowest frequency content. So this work led to the creation of Point of Departure. So Point of Departure was my first work involving direct assistance from the computer in the orchestration domain. For this, I adopted the newly released computer-assisted orchestration software, Orchidea. So I consider this piece to be a further exploration of the traditional spectral music techniques that informed the creation of my previous works for classical orchestra. My main aim was to inform both my compositional and orchestration approach from my acoustic work, Project 2. Initially, I wanted to render a complete instrumental transcription of this electronic work, but I soon found out that to be impossible due to the huge gap between the available sonic spectrum in both the electronic and the orchestral domain. Thus, with the assistance of Orchidea, I used Project 2 as a point of departure to the realization of this work. This involved a more direct and systematic approach to linking the electronic and instrumental, an approach that had a radical impact on creative control and decision-making. This example serves to illustrate how a simple sound file can output the most unperformable orchestration solution. This meant that I, the composer, had to carefully decide how to carve each suggestion into one readable orchestration solution. So in the orchestral realm, assisted orchestration can be thought of as the process of searching for the best combinations of orchestral sounds to match a target sound under specified metrics and constraints using computer assistance. Regarding Orchidea, I found two very different and useful approaches to the audio analysis, depending on the desired targeted orchestration. First, sample. The output is generated from the analysis of a single audio sample. This approach is better for a more detailed representation of the given sound file, since you are dealing with an independent solution for each given file. However, the merging of all of the different solutions into one is of the composer's responsibility. The second one, selection. In this case, the output is generated from a combination of multiple tracks or files. This approach is better for a more textual-based representation. Even so, you must bear in mind that the suggested results only resemble the given sound combination to a certain extent. Therefore, it is not ideal for a transcription procedure. This approach works best when the composer is only looking for a textural envelope and pitch sonority, such as the sound of crickets, for example. Instead of obtaining a solution for each cricket, you get a solution for the whole ambient noise. So in the electronic music domain, there is no limit to timbral blend since every combination of frequencies is made possible. Hence, the timbral gap between the timbres offered by instrumental and electronic domains meant that some sounds are rendered impossible to be achieved in the orchestral domain. Thus, these inharmonic sounds were then rendered as unpitched noise-based techniques and often percussive. Interestingly, by raising the amplitude of the recording, I noticed that the microphone also picked up the sound of a young clarinet student playing in the room next door. Instead of discarding this element as Orchidea would have done, I decided to transcribe his performance for a more faithful representation. The spatial characteristics of sound are not yet well established in computer-assisted orchestration, so I had to intuitively orchestrate this spatial effect by ear. Since the clarinet was originally recorded through a wall from room to room, it was only natural that I would instruct the clarinet player to do the same while playing his line. First, let's hear the original recorded sample. And now the acoustic version. To conclude, this meant that I had to play the game of patience by keeping both an open and critic mind to the creative input provided by the software. This approach can be helpful in providing the composer with extreme freedom if the software is used as a simple tool or the other way around, imprisoning the uninspired composer, for which every solution is more creative than the one he was thinking about. After all, the challenges this approach allowed me to deepen my decision-making and collaborative skills. So, moving on. So, the next work is plugin. Plugin is a work that, plugin. For this work, I had the initial briefing of creating an imaginative, new, and very short work based on a piece of Portuguese traditional music. In this case, the melody Lá vai uma, lá vão duas. Thus, in this specific case, I informed my orchestration from the concept of audio synthesis and processing. My approach to instrumental orchestration worked in a very similar way to electronic music composition, where processes such as delays, filters, reverbs, and synthesis are used to affect sounds. For a better understanding of this, let's hear the following clip. This video starts with the original melody being played, immediately followed by the performance of plugin.
Lá vai uma, lá vão duas, três pombinhas a voar. Uma é minha, outra é tua, outra é de quem apanhar. 7 e 7 são 14 e...
So last but not least, Paisage, my most recent work, a stereo electronic piece for headphones. This work is based on the definition of source bonding by Dennis Smalley. He defines source bonding as the natural tendency to relate sounds to supposed sources and causes, and to relate sounds to each other because they appear to have shared or have associated origins. Thus, bonding play is an inherent perceptual activity. Think about the sonic relationship between C waves and granular synthesis, or waves and white noise. The main goals of this work were as follows. As a commissioner, the festival wanted to invite musicians to create non-musical soundworks. The rules: no rhythm, no melody, and no lyrics. I, on the other hand, wanted to develop a musical composition where I would focus on the blending of sounds that surrounded me during self-isolation. We recently had to quickly adapt to work and live in the same environment, which is often full of distraction. While I was hearing all of these sounds, some of them generated by nature itself, I began to rethink the barrier of what a synthesizer could become and how a very acoustic, as in raw sampling of field recordings with no process, and electronic sounds could be so intertwined that a clear distinction between two clear sources will be very difficult, if not impossible. I then started to write a soundscape piece based on intertwining the spectrum of both the sounds that I recorded and collected and the sounds that I synthesized in order to blur the line between recorded and synthesized source recognition. So what I'm doing now. Lastly, here's a selection of what I'm currently working on. Right now, I'm in the middle of writing a piece for clarinet, bass, and electronics, where I will be merging the use of Orchidea and Antescofo, the score follower. I will start by recording the poem by Ricardo Reis and using Orchidea to generate a viable solution for the bass clarinet. Afterwards, Antescofo will be used to follow along the score and control the electronics instructions in real time. In addition, I'm also working on a composition for string quartet and electronics based on the threshold between instrumental and analog electronic noise generating sound processes. So that's it. We've reached the end of my presentation, and I hope you enjoyed it as much as I did. Feel free to contact me, as I'm always open.
Thank you, Jorge. We do have time for questions if anybody has some questions for Jorge.
Yeah, just ask away.
I'm curious about in the working with Orchidea, of course, it provides oftentimes many different solutions. And what kind of strategies do you take for either selecting a solution or distilling out of the many solutions something that actually fits with what you're trying to do? Because there's obviously a very strong cognitive component in there of selection and adjustment according to what the computer actually.
Yes, so as my background is mostly based on classical musical training, I have been studying orchestration for a few years so far. So I know what works and know what doesn't work so well. So my interaction with the software is to give it some constraints to try and to make it more, let's say, musical and more performable. And afterwards, I generate, for example, 20 or 30 solutions, and I try to see which one fits my compositional sketch the best. So it's very intuitive, I would say.
I think quite often orchestrational decisions, people always say they're very intuitive.
Yeah.
The fascinating things is, what are people actually thinking to get these things, to understand these things? Anybody else have any questions? We have a little bit of time. Yeah.
Yeah, just a really quick question, because I've noticed, like at the beginning of your presentation, you were working directly in Spear. Like you were actually doing the annotations in the graphic user interface, or did you actually use Spear with, for instance, Open Music by importing the SDIF files? And maybe a follow-up question to that. I mean, the duo between AudioSculpt and Open Music worked really well throughout the years, but we all know that AudioSculpt is not developed as it should be, even though it's a really good piece of software. So I just want to maybe just learn very, very quickly, what is your workflow? Do you work directly in Spear and just annotate because we saw like the pitches and everything? Or do you use it in relationship with Open Music or more like algorithmic based composition?
Yes, that's a great question. Well, with Spear, I don't use it that much, only for analyzing and resynthesizing sounds. The annotations were done in any software like Paint or whatever. I try to use Open Music, and I had some colleagues doing some programming for me because I can't program in Open Music. And I tried to ask them for a patch to make some automatic orchestration decisions based on the SDIF file from Spear, but I wasn't liking the results, so I abandoned that idea. And now I'm learning Orchidea to try and develop something similar, but in Max MXP. And Max is a language that I know. Open Music, no, it's not my thing. So, for example, for the piece with bass clarinet and electronics, I'm using Max for both I will be using Max for both the Orchidea and the Antoscofo software, which is a struggle for me to use a notation software to write the score, and then the language of Antoscofo, which I'm learning with Gilbert, and also learning about Orchidea all at once. So.
Hey, thank you very much, Jorge. We need to go on now. So thank you very much for a very interesting talk.
Thank you.